This video will show you how to mathematically add non-perpendicular vectors and why it works. So we've got a question, 5 centimeters north 35 degrees east plus 6 centimeters east 40 degrees north. And we want to add those two vectors together mathematically. Before I do that, I want to show you why it's going to work, and I'm going to illustrate that through graphical addition of vectors. We're going to do it two ways. First, the way we're used to. So if we have 5 centimeters north, 35 degrees east, we'll draw that little dot where we're going to start. Put our projector on that dot. And we're going to go north, 35 degrees to the east. Put a mark right there. And we'll move our ruler in. And we'll draw in 5 centimeters. And then we need to go from there, and we need to add 6 centimeters east, 40 degrees to the north. So from here, east, 40 degrees to the north, puts us about there. And we'll draw this vector in 6 centimeters long. And our resultant vector would be that one there, which we can measure to be about 10.9 centimeters. North, 43 degrees east. So I'll just write that over here. Have it. That was 10.9 centimeters north, 43 degrees east. Alright, I'm going to take that vector and I'm just going to fade it out a little bit here. Then what I'm going to do is I'm going to take these two vectors that I drew and I'm going to clone them. First this one. Scroll down a bit. I'm going to resolve it into its x and y components. This would work a little bit better if I had graph paper, but we'll make do with this. So first we're going to draw in a very faint line here. Not a vector, just a line. Then we're going to take our protractor, put it in here so that the 90-degree mark crosses it. Use our ruler. Give ourselves a little mark. Now obviously you wouldn't be able to clone this to do this. You'd have to do it on the actual vector here, but I'm going to do it on a clone for a specific reason, and I'll show you that in a minute here. Move our ruler back in. And draw our y component, or north component. Alright, then of course drawing in our x, or our east component. Okay, now we have that one resolved. Let's do the same thing. We can get rid of that line. Let's do the same thing with this vector. Oops. And we can delete that line, or you would just erase it. And draw in this vector again. Alright, so now we've resolved those into x and y components. Now what I want to do is I want to add the two x's and the two y's together. So I'm going to take two x's, I'm going to add them together, and I'm going to take the two y's, I'm going to add them together, move these vectors out of the way. Oops. Select all these. Group them together. I want to grab those other ones, sorry. Oh, I know why. Alright, there we go. So I've got those grouped together so I can move them all together. The reason I did that is that now you can see if we line these up. Now I obviously wasn't quite accurate enough, but it should reach right to that point. And you would see that when you break the two vectors into their x's and y's and add the x and y together, you get the same result. So now let's look at doing that mathematically. Let's just take this question, put it down so we can see it. And I'm going to change the question just slightly, just because what we were actually measuring was 5.0 centimeters plus 6.0 centimeters. Just, it'll make more sense later when when we look at significant figures. So we have this question, and if we were to sketch this out, we would see that that vector forms a right triangle with north 35 degrees east. Therefore, this is 35 degrees east, or 35 degrees. We know that this is 5 centimeters. We know this is the hypotenuse of a right triangle. And if we know this angle, then this is adjacent to it, and this is opposite to it. All right, knowing that, how can we figure out what the x and y are, or the north and east? All right, well, we know that sine, this is something we've covered already, but just as a quick review, sine theta is equal to, is equal to opposite over hypotenuse. Therefore, we know that opposite is equal to the hypotenuse times sine theta equal to 5 centimeters times sine 35 degrees equals, well, let's grab our calculator, put in 35 sine 0.5737. Here's where significant figures comes in. I know I have 2 significant figures, so therefore I need to keep at least 3 significant figures throughout my calculations so that I can round to 2 later. So I'll keep 0.573. So this would be 5 centimeters times 0.573 equals, I wouldn't normally, if I have it in my calculator to more digits, I can keep more digits. I just won't write them all out, so I won't clear this and put 5 times 0.573. I will just take this and multiply by 5. And then, so this is equal to 2.86 to 2 significant figures, going to be 2.9 centimeters, and that is the opposite, which is in the east direction. Okay, now to find the adjacent, the north component of this, we use cos theta equals adjacent over the hypotenuse. So we know that the adjacent is equal to the hypotenuse times cos theta. Equals 5 centimeters times cos 35 degrees equals 5 coasts, 819 5 centimeters times 0.819 equals 4.0957. I know this should be the two significant figures, so it's going to be 4.1 centimeters. And that is in the north direction. All right, so we've worked out that mathematically. Now we got to do the same thing with this one, 6.0 centimeters east, 40 degrees north. I will maybe just create a new page for this one. Oops. There we go. All right, so sketching this one out, we have it would be about east 40 degrees north, something that looks like that. This being a right angle, this being, so it was east 40 degrees north, so this angle is the 40 degrees, and this is 6.0 centimeters. All right, knowing that, and this being hypotenuse, this being opposite, and this being adjacent, let's work those out. Sine theta equals, I'm just going to pause this, work it out, and come back just so you don't have to sit through me doing the calculations. Right, there's the calculation for the opposite, 3.9 centimeters north. Then we'll do the adjacent. Calculation for the adjacent. So let's just review those quick. Sine theta equals opposite over hypotenuse, therefore opposite equals hypotenuse times sine theta, worked out to be 3.9 centimeters north. That's our opposite, or our north component. Cos theta equals adjacent over hypotenuse, therefore adjacent equals hypotenuse times cos theta, worked out to 4.6 centimeters, and that would be in the east direction. So now that we have those two components from our first angle here, our first vector here, 2.9 centimeters east, we can add that to 4.6 centimeters east. And because they're in one dimension, it's just straight mathematical calculation. 2.9 centimeters east plus 4.6 centimeters east equals 2.9 plus 4.6, 7.5 centimeters. East. And we can do the same thing with our north components. .1 centimeters north plus 3.9 equals 8.0 centimeters north. And now it's a matter of adding these two back together to get our answer. And we can work that out mathematically. Let's just create a new page for that. That was 7.5 centimeters east plus 8.0 centimeters north. If we sketch that out, that's 7 centimeters east plus 8 centimeters north. So 7.5 centimeters east plus 8.0 centimeters north. And our resultant vector would be this one. Knowing that's a right triangle, if we want to find theta, and we want to know this length, well, the length we can figure out using Pythagorean theorem. Pythagorean theorem says that a squared plus b squared equals c squared. This is a, and this is b, and this is c. That is, so the sum of the squares of the two legs equals the square of the hypotenuse. Well, to find c then, c is just going to be the square root of a squared plus b squared. Should be an equal sign in there. So c equals square root 7.5 centimeters squared plus 8.0 centimeters squared equals the square root of 7.5 squared is 56.25 centimeters squared plus 64 centimeters squared equals 120.25 centimeters squared. Oops. Equals, let's find the square root of that. We have 10.965. We know that our question only has two significant figures in it, so we can only keep two significant figures, so this would round to be 11 centimeters. So that's the length of our hypotenuse, 11 centimeters. Now theta, we can calculate using the fact that tan theta is equal to the opposite over the adjacent is equal to diagram. Opposite would be 8.0 adjacent to 7.5. 8.0 centimeters divided by 7.5 centimeters equals 1.0666, repeating. That's tan theta. Therefore, theta equals arctan of 1.066. Arctan is the same thing as tan to the negative 1. You can write them either way. So tan to the negative 1, I know on my calculator, I click inverse, and then I get tan, and it's 46.847 degrees. However, to two significant figures, that's going to be 47 degrees. So my resultant vector then in all of this is going to be 11 centimeters, 47 degrees, so that would be east. Hint, that would be east, 47 degrees north. So break that out. 11 centimeters east, 47 degrees north. Now, if we grab a protractor here, probably put it up there. Okay. 47 degrees sorry, let's do this. Let's go I just draw a dot there, and I go east 47 degrees north, maybe right about there. That is the same thing as north 43 degrees east. So I can write this answer as 11 centimeters north, 43 degrees east. If we have a look back when we did this graphically, we had an answer of 10.9, 11 centimeters north, 43 degrees east. So we can see that that mathematical calculation follows through and gives us the exact same answer as we got when we did it graphically. And that's why this works. So a quick review of the steps. First thing you need to do is break down your two question vectors into their components, their x and y components, or their east and north components, however you want to define them. Break those down into their components. Then use algebra, or just mathematically add the components of each direction, and then recombine those components back into a resultant vector, and that will give you your answer.